All right, welcome to the review video for Standard 5, Solving Systems Using Substitution and Elimination. Let's take a look at our first problem here. Oh, okay. So, notice that our method of solving this system is going to be substitution. So here's my system. Two equations, two variables, so we're good to go. My first equation says negative 6x plus 8y equals negative 18. And then my second equation says 3x equals y. So when I'm going to substitute, I want to look for variables that are already isolated. That's going to help because it makes a little bit less work. And sure enough, this y right here, right, that's already by itself. So what we can do is say, well, since 3x is equal to this y, we can replace the y in the other equation with 3x, right? So we're going to plug in that 3x for the y that's next to the 8 here. So let's do that. We've got negative 6x, that part stays the same, plus 8, and now I'm going to open parentheses. Anytime I'm substituting a value or an expression in, I want to put that inside parentheses. It is a good habit, and it especially helps you not drop negative signs. So y was equal to 3x, so that's what we're going to put in place of the y. And then it's still equal to negative 18. That doesn't change. Now we have one equation, but there's only one variable. So we can solve for x. We can find out what the value of that variable is. All right, one step at a time. Negative 6x plus, now we're going to say 8 times 3x, which will be 24x, is equal to negative 18. We'll combine like terms. These both have x's, so they're like terms. So we've got negative 6x plus 24x. That's going to become 18x, positive 18x. And that's equal to negative 18. Our last step in isolating x is to get one positive x by itself. To do that, I'm going to divide by the coefficient on x, which in this case is 18. So I'm going to divide by 18 on both sides of the equation. Anything divided by itself is 1. So 18 divided by 18 is 1. We're left with just the x by itself. And negative 18 divided by 18 is going to be negative 1, because a negative divided by a positive is a negative. Okay, so now we know what x is, but we're not done solving this system. We have to find what y is also. To do that, we plug our value that we found for x back in to either equation. You can do both to check, or if you're feeling confident, you can do one. I would recommend while you're learning, plug it into both just to be sure. So I'm going to pick this one to start with because it's a little bit simpler. So I'm going to rewrite the equation, but now instead of the x, I'm going to put in what I found for x, which is this negative 1. So again, that's going inside parentheses, and that is equal to y. When I simplify, 3 times negative 1 is negative 3. And right there, negative 3 is equal to y. So now it looks pretty sure that the solution to this system of equations is going to be negative 1, negative 3, right? Because we always write our coordinates x, then y. But to be sure, I'm going to check it. So I'm going to do the check by taking these values for x and y and plugging them into my other equation, into this equation, just to make sure that I get a true statement, a number equals itself. So I'm going to do my checking in green. I'll say -6 times the x value, which was -1, right? That's our x value, -1. Then I'm going to add 8 times our y value, which was -3. Finally, that should all be equal to -18. So again, I just replaced the x and the y in this equation with the values we found for x and y when we were solving. All right, so -6 times -1 is +6, plus 8 times -3, that's going to be -24. And does that equal -18? Well, 6 plus -24, or 6 minus 24, you could write it that way also, is in fact going to be -18. So our numbers check out. We have our solution to this system of equations. Okay, let's try another one. So once again, we're going to be using substitution. But this time, our expression is going to be a little more. There's going to be a little more to it. We're going to start in the same way as we did last time. We'll look at our equations. X equals -y minus 9. And 6x minus 5y equals 1. Well, there is already a variable isolated here, which is nice. That's really handy. That's this x right here. It's already by itself. But this time, instead of equaling a single term, it's equal to an expression, this -y minus 9. So I'm going to circle that because this expression, that whole expression, is what we're going to replace every x in our other equation with. So here's that x, right, next to the 6, and I'm going to plug this whole expression in right where that x is. When I do that, I'm definitely going to put that inside parentheses. So it looks like 6 times the quantity, -y minus 9, and we're going to close parentheses because this just said 6x, and now this is taking the place of x. We're substituting it in for x. The rest of the equation stays the same. -5y is equal to 1. Now, we're just going to follow order of operations, use our equation solving skills, and isolate one positive y. Because this 6 is multiplying by a quantity, there's more than one term inside those parentheses, I'm actually going to draw little arrows to remind myself to distribute that 6 correctly, that it's being multiplied by the -y and the -9, both of them. So 6 times -y is -6y. 6 times -9 is -54. And then this -5y equals 1, that all stays the same. It just tags along. Now we can combine like terms. So this -6y and this -5y, those are like terms because they have the same variable to the same power. So -6y and -5y together make -11y minus 54 equals 1, right? I'm changing one thing at a time. Now I want just my y's on one side of the equation and just numbers, constants, on the other. So I'm going to add 54 to both sides. Oops. And I get -11y is equal to 55. Okay, looking good. Last but not least, to isolate y and have one positive y, I'm going to divide by its coefficient. So the coefficient on y right now is -11. That's what I'm going to divide by. Both sides by -11. Well, negative 11 divided by negative 11 is 1. So that just leaves me with one positive y. And then this positive 55 divided by the negative 11, that is going to be negative 5. It's negative because the positive divided by the negative will give us a negative. And then 55 divided by 11 is 5. Okay, so this time we found y first. Now we still need to find x. I'm going to plug my y value in to this first equation because x is already isolated, so it's going to probably be a little less work to figure out what x is. It would totally work if I used this equation, but we can use that for our check. So we'll say x is equal to negative, and this time instead of a y, I'm going to write negative 5. Notice, this already had negative y, but then y is equal to negative 5. It's very important that you include both negative signs, right? This first one is from the original equation, and this one inside the parentheses with the 5 is because y was equal to negative 5. Then just minus 9, because that's the rest of our equation. Then we simplify. X is equal to a negative of a negative. Negative times a negative is a positive, so this will be positive 5 minus 9. Simplify. 5 minus 9 is, oops, got a little close there, negative 4. So now we are pretty sure our solution is negative 4, negative 5. And remember to be careful. Sometimes you're going to solve for y first, sometimes you're going to solve for x first, but when you write your solution, you have to write it as x comma y inside parentheses. All right, let's check that in green. I'm going to use this other equation just because. So I'll say 6 times x was equal to negative 4 minus 5 times y was equal to negative 5 is equal to 1. So let's see. 6 times negative 4 is negative 24. Negative 5 times negative 5 is positive 25. So I'm just going to make this a plus 25. And that all should still equal 1. Negative 24 plus 25 is, in fact, 1. So we get a true statement. We get 1 equals 1. So our solution checks out. Okay, so that substitution, take a moment, think to yourself, could I do that on my own? Was any part of that a little shaky? There are a lot of resources in Delta Math from previous assignments. You can always reach out to your teacher for additional practice. But take a moment and think, what do I need to do to make sure I'm really solid with this method? Okay. So now we're going to look at a new method, right? We just started learning this in class. And this method is elimination. Now, it's a little bit weird at first when you are just learning it, but it's actually very helpful and ideally makes your life easier. So when you're working on this process and you're feeling like, I don't know, remember, the goal is that you can solve systems in a lot of different ways, so you can pick the easiest one and the one that makes the most sense based on the system you're given. So our system is 2x plus 4y equals negative 16, and then negative 2x plus 2y equals negative 2. I could isolate one of the variables in one of the equations and use substitution. I could also isolate y in both cases, in both equations, and set the rest of them, those expressions, equal to each other and use the equal values method. I could graph these and see where the lines intersect. But this is actually a system that is prime for elimination because when I look at my equations, I notice that the coefficients on my x's are opposites. So in math, an opposite of a number is what will add to that number to make 0. So the opposite of 2 is -2, and the opposite of -2 is +2. So instead of isolating anything, I am going to add these equations together just as they are. I'm going to write a big plus sign so I remember I'm adding them. Then I'm going to draw a big line underneath. Again, looks like a kind of strange version of the addition we learned many years ago. Then we just add the like terms together. So 2x plus -2x, those cancel each other out. They're opposites. So x's are eliminated. Then we have 4y plus 2y, so we end up with 6y total. The equal sign stays in the same place. And then we add our constant. So -16 plus -2 is -18. This is really handy because now I'm just left with a single step equation to solve for y. So as usual, we're going to divide by the coefficient on y, which is 6. We do that to both sides. Our equation has to stay balanced. And we get y is equal to -3. Then we want to find our x. We can use either equation. I'm going to pick the first one, just because. I'll check it with my other equation. So I'll say 2x plus 4 times -3, because now I'm replacing this y with the value that I found for y. And that should all equal, oopsies, that should all equal -16. So 2x plus 4 times -3 is -12. So I'm actually going to change this to a minus sign. So 2x minus 12 is equal to -16. I'll isolate my term with x, which is this 2x, by adding 12 to both sides of my equation. The opposites eliminate each other, and I get 2x equals -4. Lastly, I'll divide by the coefficient on x to isolate it. In this case, the coefficient is 2, so I divide both sides by 2, and I get x is equal to -2. So now we're pretty sure that our solution to this system is -2, -3, right? X, then y. To check this, I'm going to plug both of those values in for x and y into the equation that I haven't used yet. I've used it, but I didn't use it here. So that should say -2 times -2, because this -2 is a coefficient, and then we think x is -2 in our solution. So remember, -2 is happening twice, but from different places. Plus 2 times -3. That's what we found for y. And that should all equal -2. So -2 times -2 is +4. 2 times -3 is -6. So we'll make that a 4 minus 6 equals -2. And then 4 minus 6 is indeed -2. So it checks out. Our solution is good to go. So with elimination, we're really looking for these opposite coefficients on the same variable. But sometimes we don't have that given to us right from the beginning, right? That first equation was pretty nice because we already had opposite coefficients. But in this equation, negative 5x minus 2y equals negative 1. Negative 6x plus 4y equals negative 46. I don't see any opposite coefficients. Negative 5 and negative 6, well, they're not opposites. It's not the same absolute value with different signs. The negative 2y and the positive 4y, those aren't opposites either. However, if we look carefully, negative 2 could probably become negative 4 pretty easily. So then that would be the opposite of the coefficient here on 4y in the other equation. So let's do that. Let's adjust our first equation by doing the same thing on both sides of the equal sign, right? As long as we keep it balanced, we can rewrite our equations. So to get from negative 2 to negative 4, I would need to multiply this by 2. I need to double it. But I can't just multiply that term by 2. I have to multiply every term by 2. So I'm going to write it out. Times 2, times 2, times 2. Now, you may see in other places people put parentheses around the whole equation and just write times 2 once. That's fine. Same thing is happening. However, be very careful that you don't forget to multiply your constant by that value as well. That's a really common error. So I recommend actually writing it out next to every single term so you don't forget. Then I actually want to rewrite my whole system just so that I can make sure I keep everything straight. I know what's supposed to be where, what equals what, etc. It can be really easy to get lost if you try and crunch too much work together. So when I rewrite my first equation after multiplying every term by 2, I get negative 10x because negative 5x times 2 is negative 10x. Then I'll have minus 4y because negative 2y times 2 is negative 4y. And that's all going to be equal to negative 2 because negative 1 times 2 is negative 2. My second equation, I'm just going to rewrite it exactly as it was. Negative 6x plus 4y is equal to negative 46. Cool. Now I can see opposite coefficients on the same variable. We've got positive 4 in the second equation and negative 4y in the first equation. So we are ready to eliminate. I'm going to add the equations together. Reminder that I'm adding. Then I just go down the line like I did in the previous question. So negative 10x plus negative 6x is negative 16x. Negative 4y plus 4y, those are opposites. They're going to cancel each other out. The y's are eliminated. And then our equal sign stays in the same place. Negative 2 plus negative 46 is negative 48. To isolate x, I'm going to divide by its coefficient. That's negative 16. I'm going to divide by that on both sides. So I get x is equal to positive 3. Negative 48 divided by negative 16 is positive 3. Cool. Now, as usual with our systems, once we've found one value, we're going to plug it into one of our equations to find the other value. I'm just going to use the first equation, and let's go. So, let's see. So negative 5 times 3, right? Because this said negative 5x, and now I'm replacing the x with the 3. I'm substituting in that 3. Minus 2y is equal to negative 1. Negative 5 times 3 is negative 15. minus 2y equals negative 1, right? That all stays the same. Then I'm going to add 15 to both sides because I want to isolate my term that has the y's. But be very careful in this case because this says minus 2y. When we take this next step, that's going to remain a negative 2y. That minus sign, that negative sign, doesn't disappear at this step. So be careful with that. So we get negative 2y is equal to 14 because negative 1 plus 15 is 14. To isolate y, we'll divide by its coefficient, which is negative 2. And we get y is equal to negative 7. Okay, so now we're pretty sure our solution is at 3, negative 7, right? X then y. But to check it, I'm going to plug those values in to this equation just to make sure I get a true statement. So we'll say negative 6 times 3, because our x was 3, plus 4 times negative 7, because our y was negative 7, is equal to, I'm going to move that out of the way, is equal to negative 46. Okay. Negative 6 times 3 is negative 18. 4 times negative 7 is negative 28. So I'm going to write this as minus 28. And that should all equal negative 46. Well, negative 18 minus 28 is indeed negative 46. So we have a true statement, and our solution to this system is correct. So with this elimination method, again, take a moment, think about what you need to work on. And remember, the key to elimination is these opposite coefficients. I hope that was helpful. Happy studying, and I will see you soon.